In the last video, we looked at an example of how to add and subtract two complex numbers. We found out that the key to dealing with complex numbers is to group all the real terms into one group and all the imaginary terms into another. When adding or subtracting, it's pretty obvious which are the real terms and which are the imaginary terms. However, in the Fourier transform, adding is only half the story. We have to learn how to multiply as well. When multiplying two complex numbers, as we're about to find out, this separation between which are the real terms and which are the imaginary terms becomes a little less clear. But no worries, as there's a neat little trick called FOIL that can help us out. How about if we were to multiply the two complex numbers from the previous example? 3 plus 4i times 9 plus 2i. Well, it's just like multiplying brackets. We use the FOIL method. FOIL stands for first, outside, inside, last. We have to multiply the numbers together in 4 stages. Stage 1, we multiply the two first terms in each bracket. 3 times 9 equals 27. Stage 2, we multiply the two outside terms. 3 times 2i equals 6i. Stage 3, we multiply the two inside terms. 4i times 9 equals 36i. Stage 4, we multiply the two last terms in each bracket. 4i times 2i equals 8i squared. But remember that I squared equals minus 1, so the answer to this last stage is minus 8. This all gives us 27 plus 6i minus 8 plus 36i. Now we group together the real and imaginary terms just as we did before when we were adding. 27 minus 8 and 6i plus 36i, which gives us the result 19 plus 42i. However, when multiplying, it could be easier to express the two complex numbers in exponential form, because then we could multiply them together using the exponential product rule.
The exponential product rule states to multiply two exponential numbers, simply add together their indices. E to the power a times e to the power b equals e to the power a plus b. Let's leave Euler out of it a second and take a simple example. If I want to multiply 2 to the power 3 by 2 to the power 4, all I have to do is add together the 3 and the 4 to get the answer. 2 to the power 3 times 2 to the power 4 equals 2 to the power 3 plus 4, which is equal to 2 to the power 7. Let's look at why this is true. 2 to the power 3 equals 2 times 2 times 2. 2 to the power 4 equals 2 times 2 times 2 times 2. If I write this out in full, to multiply the two numbers together, I simply do 2 times 2 times 2 times 2 times 2 times 2 times 2. If I count up all the 2's, you can see why this is the same as writing 2 to the power 7. Now the 2 could be any number, Euler's number for example. So exactly the same method works for 3 plus 4i times 9 plus 2i if we write them out in exponential form. To do this, we use Pythagoras and the inverse tangent rule. So for 3 plus 4i, Pythagoras gives us the root of 3 squared plus 4 squared equals 5. The inverse tangent rule gives us inverse tan of 4 divided by 3 is roughly equal to 53.1 degrees. For 9 plus 2i, Pythagoras gives us the root of 9 squared plus 2 squared is roughly equal to 9.2. And the inverse tangent rule gives us inverse tan of 2 divided by 9 is roughly equal to 12.5 degrees. So we can rewrite the multiplication in the form 5 times e to the power of 53.1 degrees times I times 9.2 e to the power of 12.5 degrees times I. The 5 and the 9.2 we multiply as normal, giving us 46. The 53.1 degrees and the 12.5 degrees we add together, giving us 65.6 degrees, which gives us the overall result of 46 times e to the power of 65.6 degrees times I. We can then use the polar form to convert this back into the Cartesian form and show that the two methods give the same answer. 46 times cosine of 65.6 degrees is equal to 19. And 46 times I times sine of 65.6 degrees is equal to 42i.
So when multiplying two complex numbers, either we can use the FOIL method and treat the calculation as if we were multiplying out a set of brackets, or we can convert the two complex numbers to their exponential form and use the exponential product rule to find our answer. It's a bit of a debate which of the two methods is easier. Generally speaking, when I multiply two complex numbers, I like to use the FOIL method. However, in the next video, we're going to see how to divide two complex numbers, and it is then when the exponential form of a complex number really comes into its own. Have you ever wondered why I is the square root of -1? Find out in another of my videos. See how complex numbers are used in the Fourier transform by visiting my course on how the Fourier transform works. Please consider supporting the making of these videos by becoming a patron.